Well, hi, and welcome to my shop. I hope to go the next step with this receiver, or amplifier rather, which is to determine where the hum is coming from and get rid of it. And of course I'm very suspicious the hum is coming from weak power supply filtering. That's the first area I'm going to look at. There's a number of capacitors down here, large capacitors in the cans. And I think probably the best approach here is to simply augment these with additional capacitance. Just temporarily clip in additional capacitance and see what happens to the hum level. So there's feeds coming out of the filters, coming off the capacitors. A highly filtered feed that's going into the amplifier, and then a less filtered feed that's also going into the amplifier. The less filtered one on the scope clearly showed a certain amount of hum. There. Is that really what we're hearing? I don't know. So I'm going to set this up so I can sort of click in and click out a capacitor in these different positions in the power supply filter area, and we will listen and see if the hum goes away. Let's take a look at the power supply here for a moment and just see. Now here's the 4 capacitors, 1 or 2 or all of which need to be augmented. Let's just take a look here. So this is the first filtering that occurs right here. And follow this line, and where does it go? Uh-oh, it goes out here. It goes out here just above this R116. There's R116 just above it. So you see it's 310 volts straight into the output transformer, and I'm sure the same thing's going on the other channel. So this line is the feed to the output transformers. This is the one I found was hummy, I think. Let's go back. Okay, same line is this one. And all the filtering that's on that line is these two guys here. Pretty large, 100 and 100. My little additional 50 may not be enough to I think these guys are the guys that need to be pumped up. So what's happening here is you have your classic filter come out of the rectifier, reach some filter capacitors, then through a large wattage resistor to meet another filter capacitor. So there's the pi happening. And then this signal is sent off to parts unknown in the radio, in the amplifier and receiver. Similarly, here's another one. This time it's 3K 15 watt attached to this filter capacitor, and then it heads off on its own, doing its own thing. And look what it says here. This is quite interesting. Tape, phono, FM, stereo, AM. So tape and phono, if those buttons are pushed, you would see 210 volts on this line. That's what I believe this note is saying. If you push FM, you see 135. If you push AM, you see 185. So I think what we're seeing here is, as you turn on more and more of the receiver and draw more and more current out of the power supply, you get a bigger and bigger drop on this resistor, and you get these lower and lower voltages. So with FM, you got the whole thing rocking, and there's only 135 volts pressure left because of the current draw and the drop on this resistor. I think that's what that's about. It raises an interesting question about what is it that this can power that can afford to have these different voltages on it. Meanwhile, this line is powering some other tubes, I suppose, at a very, very steady voltage. Almost as if maybe they had to do 2 things here because they knew one of them would be doing this. And they couldn't let these variations occur throughout the receiver, so they created a second power supply line that would be kept clean of this effect. That's my guess. I don't really know. So getting back to this, so if the hum is coming from here, I gotta try to stick an additional 100. If I just parallel one of these, is that going to be enough to make a difference? I gotta parallel them both. 100. Strikes me, just thinking about it, that if these are weak, if this is the problem, these are weak now and hummy, that I'd have to remove these and replace them. 100 microfarads 200 volts. Well, I think I can do it. We need to try the experiment first, though. Find out if it's really the problem. I'll see if I can cough up. Well, let's try it with 250s on here and see if the hum level's different. Okay, so I think I'm ready for an experiment here. So I've got the two augmenting capacitors here hooked up the same way they are inside the receiver, which is positive end here, negative to positive, and then the negative end out here. Let's just check my wiring quickly. So this is clearly the negative end of the capacitor, and it follows this clip to the chassis here. We follow from here on this green wire. We should arrive at the point where the two capacitors are joined, which they are, just like this, and then this should be going to the positive side of here, which it is. Okay, so everything's set up right. And then I'm going to turn on the amp, let it warm up. If there's no hum, it'll take a while to be convinced it's warmed up. Once we're convinced it's warmed up, I then remove the additional capacitance. I think I'll grab these two positive clip leads and remove them both simultaneously. And we should see what happens. What I would not recommend if anybody's doing this is fire up your receiver, amplifier, whatever it is, and then take your augmenting capacitor and then click it in, so to speak. You have a fully operating device, and then you add this additional capacitance into the power supply. You might get an unexpected result in your rectifier tube or something like that. So think about it. Power develops, kind of oozes into these things as heaters warm up. High voltage kind of oozes into it. It's none of that going on. Okay, I think we're ready. Do I have to monitor anything while I'm doing this? I think just listening for the hum is probably just going to be enough. I don't think I have to worry about any voltages at this point. We can even do this on, well, because I'm right in the power supply here, we better get an eye on those dim lights. Okay, so this will flip it on, and if I've done this backwards or something dumb, which I'm sure I haven't, which is why I may have, there'll be a big bang over here. Here we go. Okay, lights normal. Normal operation on the dim lights. Great. Now we're going to listen for the hum. So I'm watching those dim bulbs to see when they start brightening up again. Here they come. Now we're listening for the hum. The hum doesn't have to be completely removed at this point. What I would like to see is when I remove the augmentation capacitors, this hum gets louder. That would help me. So sound memory is terrible. I was told once your sound memory is good for about 7 seconds. And then you really can't do anything with your memory of a sound after that. Okay, so I'm going to remove the capacitors now and see if the hum level goes up. These are charged up to a high voltage here. I don't want to do something dumb. Here we go. Did you hear it? It actually did go up. I can certainly hear it here. So that was an increase in the hum. Now, so these are 100 microfarad capacitors, and I just added 50 in parallel with them. Conceivably the hundreds had fallen off to 50s. I don't know if that can really even happen. And putting 50 in, we're back to 100, but we're hearing a hum. The hum is either an artifact of how I've done this, set this up, things like that, which I don't think it is. This is the hum level. I don't think it is. I don't think the designers would be happy with this. I think they would want it to be hum-free. Hum-free. So I gotta put these up to hundreds. Each one, put 100 here, doubling the capacitance here. I think the hum would just come down a little more. I don't think it would disappear. I don't think this is the whole picture. So another possibility is the other capacitors are responsible for the hum, the other filter capacitors, even though I kind of convinced myself they weren't. I convinced myself by looking at the hum level on the scope and seeing there was really nothing. Well, if I'm going to continue with this approach, then I would have to parallel some of the other capacitance in there. I don't even have this on full voltage. This is probably running fairly low here. 91 volts. So for sure, if I put this up full voltage, that hum is going to become really quite distinct. It's bad enough right now. More paralleling. Unsatisfactory result at this point. We can't be sure of anything yet. Okay, so I have an additional capacitor. It's just sitting here on this white board. It's not connected to anything else. It's just sitting here connected to these two clip leads. The yellow one is already on the ground. The white one, I'm connecting through a 300 ohm resistor here. I'm going to connect it in. I'm going to charge the resistor off the power supply, or charge the capacitor off the power supply first through the resistor. Little pop. Well, out of the corner of my eye, I could see the light change over here, and it seemed to me it got less bright. Additional capacitance, less bright. Boy, that didn't add up. Okay, let me discharge this. We'll try it again. I'll do it through the resistor. I'm trying to avoid what I warned about, taking an empty capacitor and just sticking it onto the power supply. A sudden charging current from the full power supply voltage could overload the diodes that I just put in. Okay, I'm going to watch that light this time. Now I'm putting this onto this positive terminal here. Okay, did I see that? How can I add capacitance and make the light go dimmer? Doesn't the charging current of the capacitor is going to cause the lights to go brighter? Am I seeing things? Maybe I'm not seeing this properly. Let me discharge again. I'm going to stare right at that light. The problem is I can't look at two things at once, right? I'm sticking this on high voltage. Let's reverse this whole thing. Okay, hold on. Reverse this, reverse this. Reverse the arrangement. Make better use of your resources here. So I'm going to mount the resistor here. Okay, so it's connected to that capacitor. I still work as my protector. No, that's not what I want to do. What I want to do now is I'm going to clip this on. This will be live at a couple hundred volts relative to the radio. This is not. Okay, I'm going to stay there. Okay. Now I'll be able to clip this on safely and watch that light. I'm watching that light. Sounded kind of, it didn't get duller for a moment. Huh, okay, never mind the light. So this guy's charged up now. I'm going to put him right on. I'm listening to the hum level. No change. Okay, so there's another capacitor to try this with. There's high voltage on that. That's a terminal. I don't think I should stick my fingers in there. Not operating. Got all this capacitance here. The discharge. Okay, a little bit safer. So this is the power on. So I wouldn't imagine the condition of the individual sections of the capacitor here to be any different. If one's worn out, they're all worn out. If one is good, they're all good. Let's find out. Okay, first to charge this capacitor through the resistor. Okay, now we're going to add it in. No difference whatsoever. So I'm going to remove these capacitors have been in the circuit the whole time I've been doing this. I'm going to remove them. There's one. A little increase in hum. Charge. Test. Nothing. Full voltage. Charge. Can't require too much. Test. Ooh, there was a snap there. I was trying to avoid that. No variation. No variation. Hear the hum? Full power. Get this right. Wait! I'm trying to stop those things. Okay, power on, full power. Right to full power. Okay, that's definitely an intolerable hum level. I'm going to remove the augmentation capacitors and hear the hum for what it really is on full power. Wow, it's not much of a change, is it? Wow. Okay, power off. So the results of all this are simply augmenting the capacitance in here isn't going to knock that hum out. Would cutting out the capacitors that are in there now and replacing them entirely with these knock out the hum? You know, I'm not convinced that's the case. Is it possible that if I hook this whole thing up with the receiver and run it properly, the hum will go away? Not terribly likely. Given that's a possibility, should I bring the receiver in here, fire the whole thing up, and leave the hum in place for now? The hum is not dangerous, it's not hurting anything. It's not even so loud that it's really disturbing to listen to, you know, while I'm working here. Abandon the hum search for now, accept that the amplifier is safe to operate despite the hum. If I really hate the hum, I'll put the small speakers on. I won't hear the hum anymore. And carry on with the receiver and see what happens over there. How could hooking up a receiver possibly kill the hum here? I can't see it. Can't see it. Other possibilities of a hum. Oh boy. Well, I should give some thought to that. Other sources of hum. One of the last receivers I did, it turned out the hum was due to, a terrible hum was due to a poor grounding at a riveted terminal. Okay. I think I really need to look for other sources of hum that I can maybe do something to affect them to determine that they are the source of the hum. Oh boy. I don't know. I'm going to stop and think more. I got to think hard about this. I shouldn't think so much on these videos. It's too much silence. Well, I was pondering here different kinds of hum problems, including ones I don't even know anything about. I thought, hey, why don't I just check some of these resistors here, see if they're correct. So here's the story. This is correct. This is correct. These two are correct. They match what they're supposed to be. When I got to these 4 screen resistors, things get a little more interesting. Let's just take a look at this. A little closer here. On the 2K scale, 0 is 0. one resistor at a time. There's nothing interfering with this test, unless the vacuum tube is leaky when it's cold, which it can be. So this is really the resistance of that 100 ohm resistor. That one's 109. This one's 130. This one's 140. 116. So these are the resistors that are controlling the screen current or affecting the screen current. They're quite small. 100 ohms isn't going to do too much, I don't think. Now, I understand that this amplifier is built on the principles of an ultra-linear amplifier, which has a lot to do with how that screen is controlled in here. And I'm not 100% on this stuff. I'm not 100% on anything. So could variations in these resistors bring out a hum? Hard for me to believe that could happen. Is the variation in those resistors important? One of them is 145 instead of 100. That's a 50% change in a critical element. Look how they laid these out. I mean, they put in these terminal strips here to pick them up. They spent some money on getting these 4 resistors in here. All of them done exactly the same. So I think I'm on my way to replacing all those. But I really have little faith that that would affect any kind of hump, unless there's some kind of imbalance thing that's happening that's then allowing a hum which is maybe which would normally be self-canceling. Because of this imbalance, suddenly one of the hums is bigger and you can hear the difference coming out. Anybody get that? Let's check a few more resistors. I see some easy ones. So this is supposed to be 1,000 here. A little high. This one should be 1,000 here. About the same. There's the same thing over here. Again, I can't imagine how any of this would affect a hum, but you know, I don't know. So they're all pretty close to 1,000. A few more up here. This is what, I don't even know how much this is supposed to be, but I'm not going to worry about it. Smaller guys up here. Big guys are good. I'm kind of at a loss here on this hum. Do I really want to go in and change these with new 100s? I just can't imagine that's I don't think, I mean, maybe I need to do it anyway for other reasons, for distortion or something like that, but for hum, I can't see it. What if I augment the 100s down here with an additional 100? Let me try that. Let's try that. Okay, so here's my next attempt at knocking out the hum. I've now increased these 2 capacitors that were here. These are now 2 100s, so they're the same size as the original capacitors in here for the filter. So I'm just paralleling in now, doubling essentially the filter capacitor sizes here. Let me just check quickly. Negative to the chassis, positive to the positive, and the middle to the middle. Okay, so this is just paralleling those capacitors. Turn on the unit. I'm pretty familiar with the hum level now. Okay, dim bulbs because I fooled with the power supply. Here we go. Swoosh. Now that's an awful lot of capacitance in there compared to what's supposed to be there. That in itself could pop those rectifier diodes. Just wait for those lights to come back up. And we'll hear if the hum comes with it. Here they come. And here comes the hum. sure it's greatly reduced. We're on restricted power though. Let me disconnect these. More hum. So really my next alternative is to remove the capacitors that are in here. That I just... So there's 2 points of view on this. One is, yeah, you should disconnect the original capacitors, get them out of the circuit, and put the new ones in. And the other view is, don't worry about the old capacitors. They'll never do any harm to the radio if they stay in. Just because they're losing their capacitance doesn't mean they're in some way damaging. My own experience with this is, in all cases of defective filter capacitors, I have never ever seen one get hot. So if it's leaking significant current or doing something like that, it would get hot. They don't get hot. At least I haven't encountered one that was hot. So I can't imagine how a weak filter capacitor can interfere with additional capacitance being added. So conceivably this set is now running with more than its original capacitance, and we still hear a hum. Each time we add capacitance, the hum level in the speakers goes down a bit. So it's clearly the hum in this power supply that is coming out of the speaker. No surprise in that. Exactly how it's getting to the speaker may be a little circuitous as opposed to what we might think. If the hum is somehow getting into some of the amplifier circuits here, then I would expect a variation between the left channel and the right channel. One would hum, one would not. Something like that. Pretty hard to judge. I'd have to interrupt the speaker wire briefly. Let's try that. I'll do one channel at a time here. I'm going to put the power up full. Give us more hum to hear. Okay, this is really a lousy way to do this. Here we go. This is not the best way to do this, that's for sure. So one speaker off, I still hear hum. Okay. Now disconnect this guy here. I'm really intimidated with these gigantic speakers standing all the time. My ears keep whispering, "I'm gonna blow us off your head at some point." Okay. This one out. Huh? The hum is gone. It's a single channel. It's a single channel hum. Well, that's a big deal. Another big deal is shoving this wire back in. As I connected up the speaker, I don't know if you could hear it. Hey, there's no hum. What's happening here? Okay, we're on full here. It's definitely on. Maybe I didn't get the speaker connected. Yeah, that's all it is. There we go. Hum is back. Am I sure this speaker's connected? I'm absolutely sure. Stick my ear right up in it here. Oh, so let's prove it with instruments. Let's prove that it's one channel humming with instruments. Yeah. Okay, put this over here. Okay, so what I would want to try here is connecting up to almost anywhere. Hey, why don't we just run along the screens here and just see what we see. So I'm going to put this on the ground. Okay, right here. Now I do have this on full power. 28 millivolts, go down. We're on the AC. First screen. Okay. Well, there's a whopper of a hum showing there. That's what I would say that is. Let me make sure I'm triggering on the line here. Okay. And triggering. There we are. So, oh, you can't even see it. I mean, you can kind of see it. There we go. Camera work not so good. There you are. So that's quite a hum on the screen of the first two. Let's just keep going now. First tube, left tube. Can't imagine that's desirable. Next screen. Same pair. Same thing. The fact that this is filled in here is kind of weird to me too. Well, there's some very, very high frequency thing going on in here. I think. Kind of wild oscillation taking place. Okay, let's go check out the other one. The other pair. Watch your fingers. No wild oscillation, but same hum. Got a whole new problem to deal with. What about over here? Is this where he's... Look at that. So... back to this first one. Wow. Well, I don't know what to make of that. Let's go on the other side of the resistor. It's kind of like the supply side of the resistor. Dramatically different. It's not because I put the ground over here, is it? I can't imagine that. Let's just be sure. Crazier things have happened. No, get the same thing. So it looks like we've got one amplifier howling away at some what looked like a pretty high radio frequency. And the other side, happy. Which one's the hummer? You can take a wild guess. The one with the signal on it is the hummer. I'm not even sure which pair feeds which speaker. Should be able to figure that out easy by tapping the grid with anything. Almost anything. Tapping the grid. Who's the grid? Where's the grid? So we could start up here. So currently the input is grounded right out up here. I've got it on the ground, shorted to the chassis. Let's try anyway. Maybe we can hear something. Can you hear anything there? Nothing there. I don't want to stick my finger on it. It's because it's grounded. So I'm going to lift the ground. Get ready. This might get hummy or noisy. The humminess is this open wire. I was just trying to figure out left from right. Oh, that's okay. Left from right. Well, we can't do it with these wires joined. Just ignore the hum. That speaker. That speaker. Okay, so that's the end of that little study there. see. Oh! Hello! This isn't working good. Hello? Any hearing left? Yeah. These are live. Don't forget, Jim. These are live. High voltage right in front of you here. So now we seem to know the hum is in one channel and it's over here. Go look for the hum in the amplifier tube, the preamp tube, which is also an inverter tube. So we can compare from one channel to the other also doing this. So I'm watching the scope again. Just a little bit better. Where's a good ground connection? Right up here. Okay, kind of randomly picking a terminal here, one that's heading for the, so I think this is the signal line right through here. If it is, then we might see a hum right there. That'd go right on here. Oh my gosh. Wait a minute, this is the other side now. Why have I got this big RF looking bar here? What happened there? Let's go on this side. Nothing there. Let's go over here. This is the other channel. You see the bar? Heard a hum come in. And see the bar? I see it. Come back here. See a bar? I see it. This is the odd guy out. No bar. No bar for you. Bar for you? No bar for you. What is this telling me? Three of them doing something and one doing something different. I mean, you know, which one is not like the others? It would be this one. Okay, let's look at the signal on the screen. This one should be, it's clean also, even though there's a bar there, or there's RF there. That's really quite mysterious. RF, of course. And watch your fingers, Jim. Ooh, lots of RF. Look at the difference there. Low, high, kind of medium, not at all. You know what? I can hear this. Hear this. Hear this. Can't hear this. Why not? Okay, so the grid, so this is the grid. This is the grid here, isn't it? Pin 2. Yeah, this would be the grid. Cannot hear that? What's going on here? And no oscillation? You're the odd guy out. That's got the no, it's got one of the three Phillips tubes in it. I thought maybe that's the Zenith tube. It's not. The Zenith tube is over here. Well, we're on to something here, that's for sure. Let's track back a little further. So if we follow the grid, we would follow it right up onto the tube here. Likewise, let me right up onto the tube. Make sure I got exactly the same connection right here. Oh my, got a bar. No bar. Now, just to be clear, I don't think that bar should. I don't think that should happen. I think that's the indication of a problem. It's just three of them are in trouble and one is not. It just doesn't seem plausible. Okay, so again, there's no bar thing happening over here, but it's happening here. It's happening here, but not happening here on the same tube. But over here, it's happening everywhere. There and there. tube not plugged in properly. So we should take a look at some of the voltages on these tubes, and we should take a look at this on the schematic first, because these tubes, how they're being handled is a little bit unusual. So let's go study the schematic. Okay, let's see if we can figure out this schematic here. So this is one channel right here. The whole thing's here. The audio is coming in here from the receiver or record player, whatever you like, entering into this half of this tube, then over to this half, and then on its way in two ways onto these tubes. Well, kind of crazy statement, but I see how it's being done here, I think. So just looking at the output tubes here, and what is driving the grid. The grid is driven by a signal coming off the plate of this tube. Now this grid is fed by a signal coming off the cathode of the tube. When this goes high, this goes low, and vice versa. So you have an inverted signal. These are 180 degrees out of phase as required to drive the push-pull style output. So that's what's going on here. Now the interesting thing I noticed last time was the plate is connected directly with no blocking capacitor right onto the grid here. So thank you to a couple of you for sending me emails. One was particularly clear about what's going on here, and drew my attention to this, which I noticed before. This very large resistor here in the cathode circuit, exactly the same size as the one up here in the plate circuit. So when there's current flowing through this tube, and I don't know how much that current would be, there will be a voltage drop here, making the cathode ride positive relative to the ground here. It's going to be elevated. You can see right there, it gives it 58 volts normally. This is what we're going to get in and start checking around. If the cathode's at plus 58 and the grid is at plus 34, the grid is actually minus 24 volts relative to the cathodes. The actual bias on here is minus 24 volts. Right. That's quite a bit for this tube. How the biasing is done back here, I'm not sure. It just looks, I don't know what they're doing back here. I won't worry about that. Oh, here we are, cathode resistor. So you have a cathode resistor generating bias, if you like, over here. This is an ordinary voltage amplifier, I would imagine you could say that. Why they chose this arrangement? I guess maybe it has to do with achieving this, the seesawing of the voltage of this tube up and down between controlled, how can I put it? So the swing at the top is the same as the swing at the bottom. That's how I should put it. So the swing on these two lines is the same. Like if you had a 48 down here, then they wouldn't be the same anymore and this wouldn't work. Okay, I think I got enough here in my head to go ahead and poke around. Let's just read the voltages here. 190 on the plate. Well, I'm going to have to refer back to this, but 190, 58, and 34. You can find them all on this half of the tube. Pin 6, pin 7, and pin 8. 6, 7, and 8. And we can compare each tube, because there's two of these. There's the other one up here, but it's out of focus on this part of the this photograph's out of focus. So okay, we'll try that. There's really no reason why we can't compare all the pins of the two 6FQ7 tubes. But we'll start with the one that we believe is causing the hum, or is related to the tube that doesn't behave like the rest. The misbehaving tube. You bad boy. Well, I don't think it's a tube. Well, I don't know. I think it's a circuit though. So what we want to do is we want to measure the voltage relative to the chassis. these two tubes. And we can literally go pin 1, pin 1, pin 2, pin 2, just work our way around and watch what happens on this meter. Is that going to do it? Yeah. In the meantime, I'll keep the schematic up here to my side. Okay, and we're going to do it with restricted power. The voltages might be a little lower. Give it a little bit of time. Just watching the dim bulbs for them to warm up. Here they come. Okay, and there's the hum. So we'll start. We'll just go pin 1, back and forth and watch what happens here. Pin 1, 38. So that's the voltage that we're looking for, in fact, isn't it, on the grid? Pin 1, pin 1, pin 1 is the plate of one side or the grid of the other in here. Oh, careful there. You can actually see the wire going across to the grid. So 38, a little high. We're over here now. Hey, the hum come up, 19. Look at that. So something going on here. Something is going on already. We're zeroing in on it. Why? That's the same contact point. That contact point is something different about how this is wired. So maybe I just can't see something here. There's this resistor. It's not in place over here. So over on this one, there's two resistors off this terminal heading towards a tube socket, reaching two different pins. A little hard to see under this capacitor. Over here, there's only one resistor. The other one appears to be missing. Come on. Come on. That doesn't mean there's a problem, but it's pretty darn suspicious. So this resistor right here goes under and attaches essentially to this terminal. There's no resistor connected to this one. And what is over here? Oh my gosh. There's a huge voltage there. That's not the right. That's not the right. Is that the right? So there's like 300 volts here. Maybe I'm just not seeing that right. Absolutely am. There's absolutely no question. This resistor exists, but it doesn't exist over there. How can that be? Well, maybe it's this one. Coming off the other end of the wire. Yeah, this is it here. Here it is. Here it is. Okay, I found it. Okay, the mysterious missing resistor is just that. Rather than bring it over this way, they decided it was a little too busy in here. Yeah, rather than bring this one this way, they just took it to there. Okay. Okay. Mystery solved. Hum's still here though. Back to reading voltages. Back to reading voltages. So we got as far as, really we didn't get anywhere, did we? So we're starting with the that's interesting. Introduced a hum this time. 26 volts. And 18 volts. We're unrestricted power, so that may be why it's a little low. And the plates, let's just keep going around, Jim. Just keep going around. 1.3. 1. Nothing. Nothing. Wow, these wires are close in here. Could move a pin a bit and cause a short. Ooh, not quite like that. Not quite like that. 160. 165. And that's the other side of the grid, plate to grid connection. Plate to grid connection. See, that's correct. 38, 39. I don't know where I got to 20 something before. This is definitely the problem right in here. And careful, man. 40, 41, 48. The plate of the output side should have 190 volts on it on pin 6. Pin 6. There you go. 1, 2, 3, 4, 5, 6. This should have 190. Oh, son of a gun. 160. And this should have 190. 160. Okay, that's okay. Low because I've got restricted power. So the problem, the variation seems to be right on the grid to plate. Let's check a couple of resistors out there. Power off. Orange, I think that would be, what would that be? 30K and going up. Again, doing these in circuit tests is really quite questionable about what I'm really reading. I don't know what I'm doing. So let's just recap here. Found a voltage variation, a dramatic voltage variation. Haven't tested these tubes yet. I can test them now. These tubes can be tested because I know. Hey, let's test those. We're going to test these two tubes. That's what we're going to do. Test the two tubes. Okay, rather than put these tubes in the tube tester at this point, I'm going to swap them and see if the problems get swapped too. Because that can be done very easily. These tubes say Rogers on them. Both of them. So we got a Zenith, we got Philips, we got Rogers in here. So now what I think would happen is the strange voltage would show up here and the hum will show up in the speaker over here. What I got hooked up, I still have, I do not have the augmented capacitors in here. Why would I add them? Why would I add them? I wouldn't. So we're going to remove these clip leads and get them out of here. And reduce my chance of getting confused or doing something dumb. I had to buy this in college. Did I mention that? I still have it. I still have it. That's a general statement. Okay. Tube swapped. A little hard to do the hum test again because I'm having some trouble hearing which one's humming, but maybe I can tell even without any more. Let's just keep an eye on the dim bulbs. Up and on. Down they go. Now the heaters are heating up the tubes, and the tubes will start conducting. That's what we're waiting for. Anytime now. Here they come. And do we hear a hum? And there's a hum. Where's the hum? I don't think there's any doubt. The hum has remained in the same speaker. I don't think there's any doubt of that. I'll be smart and switch this over to voltage. Check the grid voltages. And see if it moved. The problem moved with the tube. Here we go. 37's appropriate. Clearly not. It's much lower. Lower voltage. What am I doing here? I want to turn off the power. These wires that carry nothing. Noisy 165. Noisy 165. Next one's the same as the first one we did. 48. 42. Slightly different. Here, 0, 0, 0. So that makes perfect sense. The one in the middle is grounded. 0. We don't hear that one. I've been here before. What's going on here? Swap output tubes. This guy's silent. 200. Oh, I just won something. Did I win something? Swap output tubes. Just going to swap these two. What do you do with your old socks? Here's what I do with them. Anybody recognize this character? You might have to be Canadian. I'm not sure about that. Okay, so I want to reach down and grab one of those scaldingly hot output tubes here. Wasn't it Sherry? Sherry was the that name match with this? We're going to find out it's a defective tube. So this kind of problem, when it's inherent in a tube, is really hard to nail down. Power's half off. Make it fully off here. Sherry Lewis, wasn't that her name? And I can't remember the name of the character here. Okay, I did swap those tubes. I know I pulled them out and stuck them in, and hopefully I swapped them. Too busy remembering my childhood. Okay, we're going to need the voltmeter. What we're expecting now is to find that the lack of sound will be here, not here. Okay, we're ready to power on, powering on. So I think I have one 6BQ5 tube somewhere in my house here. Are we ready for this? Here we go. Let's start over here. Hear it? Hear it? I don't hear it anymore. Oh my god, I don't hear it here either. Well, that just may be whoop. I really broke it now. Bad pin contact? Doesn't seem like it, does it? I moved a bad tube and blew something up. Put them back. Put those tubes back. I can't explain the result. Not so hot. Not so hot. Ooh, that's a hot. How come this one's hot? Hot, hot, hot. Not so hot. Conceivably, this is the good one. Really, not so hot. Okay, so now we think we're in the position we were in before with the won't make a sound here. But they make a sound everywhere else. Here we go again. Power on. It's another reason why although I've never experienced this, going to a doctor and having him make an assessment based on a one-shot test. Wow, I don't think I'd be comfortable with that, considering, look, I'm doing these things over and over and over to try to get it sorted out. It just means it's a good thing I'm not your doctor. That's really all it means. Okay, so a little bit of a loose connection down here. We'll ignore that. There we go. Make a sound. Make a sound. Make a sound. Make a sound. Somebody answer the question of what is going on. So clearly moving the tubes did something. Oh, it's this connection that's loose. Well, I'm going to hunt down my spare tube. That's what I got to do next.